2024 was really the year of agents that looked good in YouTube videos and demos, but sort of fell apart in production.
Give us a sense of what is the AI tooling for you today?
I mean, I've seen firsthand, and I'm using that all day, every day, really. It's an absolute amplifier. I think if you don't know how to code, you'll quickly get into a situation where you're kind of stuck. But really my point is that you're focusing less on the actual data and the sort of content of the data and more on the actions or tool calls that the agent made. You being kind of an expert of this thing really puts you in a position to design an agent like probably better than most. And I think the designing and building of the agent is not as hard as it might seem from the outside. Now's a great time to jump in if you haven't, honestly.
Hello, everyone. Thanks for listening to another episode of Data Innovators and Builders. Today, I'm speaking with Alexander Page, Engineering Director of Applied AI at BigPanda. Alex, thanks for chatting with me today.
Yeah, thanks for having me on.
So Alex, would love for you to give a quick introduction about yourself and how you got in the world of AI agents.
Oh man, it's tough doing that quickly, but I'll say I have always loved technology, fell in love very quickly. I think I was maybe 6 or 7 years old, got my first Toshiba laptop with the eraser mouse. And I just kind of always knew that I wanted to do this or something in technology my whole life. And that has remained true. I studied computer science, started my career as a developer, then moved into sales engineering or pre-sales. So kind of running technical demos of software solutions, running POCs, POVs with prospective buyers, sort of the technical side of IT sales, if you will. And I was doing that at BigPanda initially, and then ChatGPT came out, and I just very quickly saw a huge opportunity to apply this sort of new wave of AI technology to what BigPanda, the space that BigPanda sort of was already in, being IT operations, very data heavy and often like very cryptic, at that. And, this need to sort of understand all these different signals and humans really struggling with that. No surprise. I think, LLMs and agents are a great fit for bringing a lot of efficiency and improving the quality at which we do these things and sort of run operations. So that became very clear to me very quickly, and I just sort of dove right into experimenting initially and prototyping. And fast forward a couple of years from then, I'm now running a team at BigPanda to basically do just that. So yeah, it's been an interesting journey.
Yeah, that's awesome. That's incredible. I think when talking to you, I feel like you are one of the most advanced people in terms of using agents and building solutions off of that, and actually thinking about some of the more sort of cutting edge areas when it comes to creating an agentic solution, right? So maybe let's just start with what are some of the top of mind things for you? I think when we were starting, at some level, the conversation was about production grade systems, and in that context, I think you talked about guardrails and evaluation. So you're clearly well ahead of the folks who are still testing ideas. You have taken them to production. Tell us a little about that.
Yeah, I think 2024 was really the year of kind of agents that looked good in YouTube videos and demos, but sort of fell apart in production. And I would claim that we're the only company, even in this space, that's finding some success and sort of finding the secret sauce for that. But it's a majority of our sort of research efforts are around, how do you go from something that clearly works and the prototype is extremely viable, but how do I account for all the sort of production setting situations that it's going to find itself in? And still work reliably, still get the right answer, at least most of the time. And then, really along with that, how do we build these systems in a way that they learn, right? And that can take many forms. But the key is that they improve. If they don't get something right, then they need to be able to get it right the next time. Yeah, I mean, this topic in and of itself could take up the entire time. I think it does matter if, like, when you're saying agents in production, like, are we talking the target audience being smaller companies, mid-sized companies, or larger kind of enterprise companies? There's different considerations, I think, in each. I can speak primarily to the enterprise side of that. So things like guardrails matter quite a bit. We can't build these systems in a way where they can really go cause harm in terms of action that they're taking. So the obvious mitigator for that is human in the loop in terms of actually taking action. When you're kind of building agents to more generate insight or make suggestions, and they're more or less doing read-only operations on different systems or looking at data in sort of a RAG context. Guardrails for taking action, you don't. Well, if it can't take action, then we don't really need guardrails for that, right? But even that, like data access, right, and being able to honor the permissions that a given user has. If that user's interacting with an agent, we should probably reflect those permissions in the systems that it might be getting more information from. So that's a consideration. Guardrails on making sure that we're not even letting the user get information that they shouldn't get. So there's a whole, area to and there are solutions for this. But I wouldn't say that it's an entirely solved problem.
Yeah, I think through this conversation, let's peel the layers of that. But maybe to back up, why don't we start with, is there a framework that you use in deciding, what use cases you want to take to production? Or, which use cases to go after?
Yeah, there's sort of two avenues. One is, we dedicate time to do really pure research on looking at the space holistically, and that being for us IT operations. I think it's critical that if you're building software, that you're talking to your customers, and so you'll get a quick sense of like what problems you're solving well, what problems that you might be able to solve in a better way, and then what are the problems that you're not actually even looking at yet at all, right? So if you're in touch with that, then naturally, you will start to think of new ways to solve problems, and then that can translate into sort of prototypes, and it's sort of like try 10 things and maybe one will stick kind of thing, or you take more of what you actually look to do and like what you prototype around is directly things that customers are asking for. I think you kind of need both. You need to be able to accommodate what are the immediate needs that are being voiced and communicated by your end users, by your customers, and then but also like take the step back and kind of rethink the game entirely, sort of thing, and that might translate into one or many prototypes, right? It's sort of the classic, figure out what your customers want before they realize they need it, kind of thing.
And do you typically approach this with make multiple prototypes depending on what's coming in, and after you build the prototype, figure out what's really the high value? Or sometimes you realize that some use cases are extremely complex also, and so how do you go about that? Is there something you would recommend to the listeners?
Yeah, I think it's sort of the classic, like, for any larger or more complex problem, break it up into parts, try and solve them individually is typically a winning strategy. And it was the case maybe 2 years ago where we would know exactly what we want to achieve, but it might not have been possible with the current state of, say, foundation models, and even just simple agents back then were not so reliable. And since then, tool calling has improved so much, and there's just so much more that's possible today, I think. Yeah. And so it's now more that, like, most things are achievable. It's just how you approach it and how you design the system. And I think breaking things up into chunks worked 20 years ago in programming, and it still works today in designing these systems.
That's absolutely right. I think breaking that down and clearly capabilities have certainly improved. I think one of the things that when we were chatting earlier, we're talking about the role of data quality in this, and if that if you have any sort of thoughts or comments on how do you handle those quality issues or data quality issues when you're working with LLMs.
Yeah. So I think it's two things. It's data quality, right? So and we'll take some examples. So
Yeah. It'd be great
a
to work
big part
with
of our system is, so the system that I primarily work on at BigPanda is called Biggie, sort of a personified kind of AI system that does many things, but one of those things is understands and internalizes history and context of a given organization, and can, I'm dumbing it down quite a bit, but can rag across that data, right? So you're talking Confluence pages, ITSM data, wikis, knowledge base articles, SOPs, all really IT operations related, but in many different forms, structured, unstructured. And so then you talk about data quality. So I might have a Confluence page that's describing how to wave bounce, these app servers on a cluster or something. And that was written 2 years ago. And there's one step that's not quite right anymore. We don't do it that way. Now we do it this way. But well, that's how would an LLM or an agent understand that this step is out of date or wrong? It's not going to know that, right? So you serve up to the user, do these 10 things. This is where I got it from. So I think an important part of that is traceability. So citing sources if you're building a RAG system, it's not sufficient to just give an answer. Even if it was based off context, you need to cite that context, because then a user might try those steps and realize, step 7 is wrong. We don't do it that way anymore. We do it this way. And now that's the pivotal moment of what do you do right there, right? So can the user easily say to your system, well, that was kind of good, but this step is wrong. We don't do it that way anymore. And then can you internalize that, right? One approach would be to try and programmatically fix the data in the source system. Probably don't want to do that. The other approach is to highly recommend that they fix it at the source, but they may or may not do that. An approach that we've explored and have taken is more, okay, well, let me now internalize that, and I'll handle conflicts when they arise. So obviously, user corrections, right, should take a pretty high weighting, not infinitely so, but then the next time when I'm kind of getting a similar request, I find that same out-of-date Confluence article, which unfortunately they didn't update it. And now I see that, but when Bob asked me this, this was something that he said was wrong about that context. And so you can sort of then, LLM can obviously handle the kind of blending or the merging of those two things, is one approach. But I think the data quality is just one part of it. There's also data gaps, right? Well, what happens if I say, help me do this, and we don't have anything? There's nothing to retrieve, right? How do you handle that scenario? I think that it's very important to track these sorts of things and make them available to more of your power user or admins on the customer side, so that they can figure out what to do with that, right? A lot of users are asking questions about this, but there's nothing in our context, or, we don't have a Confluence page for that, or whatever it is. That's a data gap that we want to do something about, right? I think at the very least, you need to be able to show that. What we will see though is if you don't have any, you come up with all these magical answers, and then I can't answer this, and your system sort of gets blamed. Oh, it's not that smart. It didn't know that, right? So I think it's these systems should kind of feel human. Like, hey, I searched everywhere and I don't see anything for this. Like, and you can kind of curtail those perceptions a little bit with how you handle those scenarios, but they should be expected, because they will 100% happen.
Yeah, I think exactly right. I think one of the part that you're talking about is also like there's some sort of a human in the loop now, all in these cases where we are sort of learning from that interaction, right?
Mm-hmm.
Yeah. So,
yeah.
And how important is that as you're designing a solution to figure that part of the interaction, taking inputs from the users, or is that happening usually in the testing phase, or is it also happening that in the actual production use where you have a human in the loop?
So as far as being able to correct the system,
Correct. Yeah,
or
exactly.
right,
Being able to
I
bring in
think that
corrections. Yeah.
yeah, I would almost go as far as to say is if that's not, if there's not something in place for that, that it's not going to go well, right? Because I don't think the expectation is necessarily that these systems are perfect, but I think that there is a growing expectation that when they mess up or don't know or can't figure something out, that they can be taught or shown the correct answer, and then it should get it right the next time. I think that is a growing expectation. So if we're sort of building these systems that are sort of as good as their data, or and can't be improved and can't kind of morph or adjust or adapt to different needs of different customers, the success is going to be you know is going to be negatively impacted of that system for sure.
Okay. Yeah, yeah. One of the things, Alex, that we have noted in building an agentic solution ourselves, where it's a bit of a data engineering agent, is that when you talk about the agent should sound human and it should sort of have a natural response, a lot of the work that we put in went into prompting side of things, and also sort of enriching the context that we are bringing into the model, right? Any anything you might want to share on that side, like techniques that you have seen?
Yeah, I think those are sort of the two main levers. Fine tuning is another. I'd say for a lot of our needs in this space, we've found ways to achieve them without needing to fine tune. But I think that has been made a lot easier to do, and shouldn't be overlooked. But yeah, I think a lot of it is prompting. I think one area to like really pay attention to is what you mentioned, context engineering, right? So even though context windows are increasing and will likely continue to increase, agents or LLMs, still suffer from, it's within the context window, but it's a lot of context and it's going to struggle. And everything from kind of lost in the middle type of problem to just the answer is just not that great, or it didn't adhere to all my instructions because it was just inundated with the mountain of like retrieved context that I pulled in because I'm not doing any chunking or re-representation. So it's just, these, I'm sort of taking the source documents that I'm kind of indexing, and then just kind of one for one, they become a retrievable document. That can quickly lead to, this problem of overwhelming the LLM, where responses degrade. So I think I've seen context engineering kind of coming up a lot more recently. It's something that maybe just as a product of being early, something we realized pretty early on we needed to address. And it's sort of nice that a lot of our initial kind of indexing and retrieval, that part of our system was built around the 32K token context windows that we had back then. So now it's like, oh, I have 1 million, but I think it's important to not to fall under the impression that, oh, I can fill up, the whole context window and it'll work just fine. You'll quickly realize that that's not true. So there's, what do we do with that? Well, we can prune, right? It's just because something is semantically similar above a certain score threshold, doesn't necessarily mean it's useful. It doesn't necessarily mean the whole thing is useful. Again, can handle this on the retrieval side, or we can handle it on the indexing side, chunking, re-representation, different costs associated with those things, but can dramatically improve results. And again, we're talking purely like in a sort of a RAG system context here, but I think most agentic systems should have some sort of kind of RAG component to them as the source of information not available in the pre-trained data of a given LLM, as a source of, user corrections, as a source of how to approach a problem, and as well as a source of history, for a particular customer organization.
Yeah. And especially as we're talking about the context engineering and building some of these, one thing I think I want to definitely ask you about is the AI tooling. If you can maybe share with us how you have approached solving this. You mentioned, using Cursor and other things, tools before. Give us a sense of what is the AI tooling for you today.
Yeah, I think a lot of attention on this topic, especially recently. The way I look at it is, and really it's in the context of software development, right? There's all these activities that we, as engineers, perform, from writing code itself, but even designing systems, designing infrastructure, sort of like building the Terraform for a given system. Then there's reviewing code. There's writing tests. There's all these activities, and really for all of them, there is a number of different kind of AI native tools that I think in general, I wouldn't say all of them do all of them better, but they can give you a level of scale. And if nothing else, it's another set of eyes. I'd say, like, for things like the actual, like, coding AI tooling, like Cursor. I mean, I've seen firsthand, and I'm using that all day, every day, really. It's an absolute amplifier. I think I'm somewhere between 6 to 10 times more productive, and like actually that much, through, and not just using these tools. I think it took a second to sort of figure out how to use them effectively. You sort of have to get used to the harness of each one, right? So I know, down to the point of, like, I know in Cursor how to prompt Sonnet 4.5, versus Codex or GPT-5, also in Cursor, right? They're sort of all behave differently, and I kind of know which one to use for, like, say, UI kind of heavy, really making the page look nice, versus some back end, more like algorithmic processing logic. But I think you just naturally pick that up as you start using them, and then once you get more familiar, like, I've seen it in not just myself and other people on the team, the effect that it can have. I think if you don't know how to code, you'll quickly get into a situation where you're kind of stuck, right? Because when it gets stuck, and it definitely does, or even worse, doesn't get stuck, it's confidently wrong. You need to be able to know how to spot that, how to remediate it, redirect it, and sometimes kind of take back the reins and sort of fix it yourself. If you don't have that background, that's going to be a lot harder to do, obviously. But I think someone who's kind of has coding experience already, and maybe some professional experience, writing code, not just in college, so to speak, can be very effective with this tooling.
Oh yeah, I mean, I 100% agree. And one of the things I feel is that to be good with these tools, the important skill is to know what good outcome looks like. So you can sort of keep judging, like, okay, this model is doing better for this use case, this model is doing better for that use case, and there's a constant learning process, as well as the models themselves keep changing and evolving, right? But knowing what a good outcome looks like is almost like a necessity. If you don't know that, if you don't know what code should look like, then it's very hard to get to that outcome, right?
Mm-hmm. Yep.
Continuing on the tooling, I think one of the things that I wanted to also ask you was about evals, right? You build a system, you put it out there. How are you building confidence around the quality? And one of the things I think is about consistency, right, of outcomes. So maybe share with us a little bit any lessons or guidance that.
Yeah, evals is a very broad topic, right? I think at its core, what you're really doing is you're trying to evaluate the output of an LLM, right? And there's a number of things you could evaluate. Is it correct? Is it too wordy? Is it aligned with human values? Is it is it misleading? Is it whatever, right?
Yeah.
So there's a lot of different ways you can evaluate. So first is identifying, what should we actually evaluate? But then you talk about agentic systems, right? Where if I want to evaluate an agent, right, that becomes quite a bit more difficult, because you really, if you want to do that right, you'd want to and not just evaluate the final output that agent might produce, but the intermediary steps, right? And I think you actually, if you do that, then you'll be much more effective at actually identifying the source of problems when they arise, and making a more predictable system. And so, really, if you think about like what an agent's doing, right? It's well, I guess we'll start with just more of like a stateless LLM call, not an agent. I have a prompt. I, you know, push that via API to some LLM. It gives me a response, right? Sort of like I'm on ChatGPT and I ask a single question and I get a single response, right? That's one thing. You're talking about an agent, and really, I think the simple definition for an agent is it's an LLM based application that's where the LLM itself is deciding the control flow. So it's deciding what to do, and how it does that is you make available to the agent what are called tools, but you could think of those really as just functions, and those functions can do whatever you want. They could be retrieving context from a vector database. They could be creating a ticket in Jira. They could be, doing math, getting the current time. Much more complex things like these tools can really be whatever you want. But that's sort of how you break up the different kind of capabilities that you want the agent to be able to have access to. And then you simply provide those tools to the agent. And when that agent's invoked, it sort of kicks off this agent loop where there's some input to it. Hey, go, look this up and then create a Jira ticket. And then it says, okay, well, what tools do I have access to? Well, I can create a Jira ticket. That's a tool. But I should probably go look this thing up first. And I have a tool to go look things up. I'll call that tool. And that then returns a response. Then the agent's back in its sort of decider mode. Okay, I asked that tool this, it gave me this, and now what should I do? Well, I need to create a Jira ticket, and I think I'm ready for that. I'll call that tool, and I create the Jira ticket, and blah, 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 right? So if you're evaluating that, well, what if the agent first just skipped right to the Jira ticket, right? It maybe assumed it had enough information, but it really obviously didn't. And so it just made one tool call, create Jira ticket. And that would obviously, you would fail that evaluation, because your evaluation expected result would be that it calls two tools. You care maybe less about what the response of the tool was, unless you're controlling the test data. Then, of course, you can be more deterministic with that. But really, my point is that you're focusing more on less on the actual data and the sort of content of the data, and more on the actions or tool calls that the agent made. And so that's where we tend to focus our evaluations, because a lot of the things that we're doing, it's not just a single agent. Even it's tiers of agents or hierarchies of agents and agent teams, and in the entire agent loop, 30, 40, 50 tool calls. It would be quite cumbersome to evaluate the response of each tool. Even it's more straightforward to sort of enforce, well, for this sort of thing, this is the sequence that should occur. And so that's where we focus more.
Yeah. Okay. And again, you're orchestrating a whole sort of layer of agents, right, to get the task done.
Yeah. And well, in many cases, yes. The way we've designed our system is to sort of make the input easy. So as a user, I don't need to know really any of this. I know what I need or what I want. And then we internally will figure out at runtime, well, what do I need to spin up? Can my wrapper agent, can I handle this? Does it need to spin up, 1, 2, 10 sub agents? Do I need this team of agents over here that specializes in this thing? So we sort of decide, what we need at any given time.
Yeah. So basically getting that user intent, interpreting that, then, of course, working the agents around that. I think one of the things that we talked about was also like, having two agents and different responsibilities of the agents. Or how are we defining that? Like, is it taking one small task and saying, here's the job responsibility, almost like a person?
Yeah. Again, it's, interesting. An interesting thought is sort of, do we design our systems around the capabilities of today, of the foundation models today, or do we approach it maybe differently? And maybe we know that one day, and maybe, the next generation that comes out, this will be feasible, but right now we can't do it, or we have to do it this other way that's less ideal. I think that's important lens to look at everything, right? So going back to the earlier conversation of like, what do I choose to prototype or not, and like when is it failed, or do we bring it forward? We have a whole shelf at any given time of things that aren't possible today, but we know we want to do, and we know that they're going to be possible soon. So I think, I think that's thing one. Oh, I lost my train of thought. What was the? Can you repeat the
Yeah, no,
question?
I was just thinking about defining the responsibilities of an agent. Yeah.
Yes. Yeah. So if you, let's say you have this kind of big, large system that all you want it to be able to do all these different things, and that ends up with, let's say, 100 different tools, right? If you add those 100 tools to one agent, it's going to struggle. It's not going to know. It's not going to be good at figuring out which tool to call. So in general, again, it's the same thing of, if I have a prompt to an LLM that's 50 tokens or 100 tokens or even 1,000 tokens versus 200,000, in general, it handles less tokens better. And the same is true of agents deciding which tool calls to make. So a lot of it is really just isolation of decision making, right? And it's pretty natural to design it that way, because it's almost like if I was designing a team of humans, right? I have a couple of developers, they write code, a designer, they create Figmas. I have a PM, they decide what we do. I have a support person, they handle, issues that are report. Like, so you sort of, you don't want to limit yourself to what humans are capable of in terms of how you design these AI systems, but I think it's a good place to start. And so that's one approach to kind of how you break down something into a series of agents. I think, keeping them kind of domain specific, even like if you're building, say, an agent to interact with a certain system, and maybe there's a number of ways to interact with that system, different ways to get data out of it. You might want to have a single agent just for interaction with that system, right?
Yeah.
You might have, and I think there's sort of different layers involved too. Like I might have a set of tools that I want to give to one or many agents. Maybe like some of my kind of context retrieval tools and like basic kind of date time conversions and calculator functions. And, that might be useful for a number of different tools. Okay. So we have sort of shared library of tools that we give access to different agents. But in general, I think as much as you can sort of focus them in terms of the tools they have access to, and then therefore the system prompt, right, that kind of kicks that agent off, the results tend to dramatically improve when you get that right, I think.
Yeah, absolutely. And I think maybe this also points to one thing that is perhaps a source of confusion out there about MCP, right? And from the outside, sometimes people feel like, oh, it can solve all my problems. And where have you maybe, or how would you, what advice or input would you share about working with MCPs, or any limitations that you have seen and worked through?
Yeah, I think it is a term it's used a lot. It's maybe perhaps not so well understood. It's basically a standard for how AI systems can get context or get data out of other systems. And really, all the protocol itself exposes is tools, resources, data context, sort of thing, and in some cases prompts, right, or sort of like prompt templates. But I would look at it as sort of more of like it's like a standard plug, like USB-C kind of thing, so that when you're building, say, an agent, and it needs to have certain access to, say, Jira or ServiceNow or Dynatrace or whatever, some other system, that you have an easy way to consume tools of those external systems in the agent that you're building, so that you don't have to define them yourself, right? But that doesn't mean that it is sort of this kind of cure-all, and it does come with challenges, because even security wise, you're sort of trusting the MCP that you're pulling in to have handled that, and right, so that you shouldn't assume that, and you should sort of vet that. I think it's also sort of abstracting out certain logic that you then have less visibility into sort of how it's happening, and maybe in a lot of cases that's okay, but it can make it a little bit more it can make it more difficult to troubleshoot when things are going wrong. And if some input to that tool that you're pulling in remotely is now resulting in very different outputs, you don't really know why, and you can't know why. So I think there's pros and cons. I mean, the nice thing is I didn't have to write the tools myself, but then, obviously it's harder to monitor, harder to guardrail, harder to troubleshoot. And I think that there's also sort of like, there's MCP, but then there's also A2A, right?
Yeah.
And I think the original intent with MCP was really all around data. I mean, it's model context protocol, right? So it's all about getting data out of some other system. But so like for us, we're building an agentic system, and maybe some of our customers have sort of built their own agents and they want them to talk to each other. And then it's like, oh, well, let's use MCP. But really, there's another protocol that's more better suited for that, which is A2A, which is something that Google put out, right? And it's agent to agent. And one of the primary differences with that is it's sort of keeping, not hidden, but it's not exposing the inner workings of each system, but letting them still talk to each other effectively. Which I think there's a lot of benefit in that from like a kind of an enterprise software perspective, right? So yeah, I think it's it's a good topic. It is. I kind of think of it as a little bit of a snake oil type of a thing as far as how it's being used. I've heard, wrap your chaos in a standard and call it governance kind of thing. But yeah, I think when used properly, it can be a nice sort of easy button to really beef up the capabilities of an agent or an agent system without having to rewrite, something that some other system is probably better suited to own.
Yeah, no, exactly. And I think there is some overhead in the way some of these mechanisms are working. And but I would certainly say that to your point earlier, and I agree that where things stand today and the amount of progress, there are very, very solvable problems. Do that consistently, put the guardrails around that, have, evals as you build that. And we can certainly go from being in that prototype mode where, yes, this looks cool, AI can really solve a problem, but going from there all the way to like have a production system that's running 24/7 and solving problems. I can trust it. It's consistent. So this certainly, it has become, possible to do that. But I feel like we're at the starting point of some of that evolution, right? And some of the things you mentioned today as approaches are super helpful in thinking systematically about how am I designing my agents and how am I thinking about the problem and sort of putting a system together, right? So anything you want to add, maybe, Alex, as advice? Because I know a lot of people are looking at building that sort of production grade solution, but any learning tools, any other sort of piece of input?
The only thing I would say is I think the accessibility of this technology is like the most incredible thing about it personally. Like I don't have a background in ML, right? But I feel like I have learned a lot about them and all really through doing, lots of YouTube videos and, but primarily just like experimenting and kind of banging my head against the wall and kind of figuring it out. And also, getting help from LLMs, from ChatGPT, a cursor, along the way. But, I would say like, I've seen it already firsthand. If you're an expert of something or you understand some slice of data really well, I think that it's so accessible that it's really not as far-fetched as it might seem to build an agent on top of that. And I've seen several people kind of make that leap, from PMs to support SREs, and you being kind of an expert of this thing really puts you in a position to design an agent like probably better than most. And I think the designing and building of the agent is not as hard as it might seem from the outside. There's a lot of things that make that easier, from frameworks to just like a wide, just as many YouTube videos as you could possibly watch are out there. But things like, LangGraph, Agent SDK, OpenAI just put out even like a WYSIWYG editor for building agents. So it's just getting easier and easier and easier. I think now's a great time to jump in if you haven't, honestly.
Yeah. Well, I think that's fabulous career advice, actually. And I would agree with you that, a few years back, if you wanted to do anything AI, ML related, it would easily take a year of, building that and training and getting some sort of, small use case to production. And here you are, like the whole power is right accessible to you. And now a lot of the problem is about stitching together the right pieces, thinking through the system design very well, and really thinking like, hey, this is the outcome I'm trying to get to, and how do I do that? And you're right, that takes a lot of banging your head against the wall, and also sometimes getting surprised by new models that come up, and like all of a sudden the problem is getting solved, right?
Right. Yep.
Yeah. Awesome. And I really love your title in that sort of applied AI, right? And I feel like probably there'll be more of those sort of roles for people out there who are willing to put that effort and learn that applied AI side, because there's tremendous value, I think, in enterprise to create in that function.
I agree. Yep.
Yeah. It's been such a pleasure chatting with you, Alex, and I've learned a lot, and I think our audience will learn a lot as well through the conversation. Thank you so much for joining us today.
Of course. Yeah. Thanks for having me. It was great.
Thank you.